All right, for number 25 on the homework from 2-4, your rates of change in tangent lines, what you're doing is you're trying to find the slope of the curve of your area function at the point 3. So a would equal 3. Remember, slope of your curve is given by, your slope is usually its rise over run, which is your change in y over change in x. And the way we change our y is, you have the f of x plus h minus f of x. Remember, x plus h is just some domain element slightly to the right of x. And then for your run here, well, we take the difference of these values. It's x plus h minus x, right? X plus h minus x. Oh, wait, x minus x is 0. That's why we get that f of x plus h, minus f of x all over just h. And when you're taking the slope of the tangent line, remember, we're taking the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay? And since we're taking it at 3, we're not just taking it in general. We can substitute 3. You can either substitute 3 into the x because we want to take it at this particular point. You can do that now, or you could do it later. I'm going to go ahead and keep it as x. Remember, our function, if we want to find out what f of x is, well, we're doing the area of a circle. Area is given by pi r squared. So that's the function we're dealing with. If you see, they say with respect to the radius. The reason they say this is because radius is the only independent variable here. So we want to use this r as our variable as opposed to just x. So here's what we have. So we take the limit as h approaches 0 of our function evaluated at x plus h. So instead of pi r squared, you can do pi r plus h squared. Remember, we're only squaring the r squared, so don't put pi and square that. All right, minus f of x, so minus pi r squared all over h. Okay. Then you just do some algebra to figure that out, to figure out what you're supposed to get there. So I'm going to go ahead and give myself a little more room to work here. So let me push this down. All right, so what you're doing here is now we can plug in the particular r that we want, or on your formula, on this formula, by the way, this formula for the slope of a curve, it's actually this formula right here. That's on the top of page 90 in your textbook. So page 90, and that's the definition of the slope of a curve at a point. Here, the point in particular is x equal 3, and then the y value would be 9 pi. So we want to find the slope of this when our r, in this case, because r is an independent variable, not x, when that thing is 3. So we can do this. I'm going to go ahead and substitute that in. So it's the limit of pi of 3 plus h squared minus pi r squared all over h, and that's the limit as h approaches 0. So expand this out. I'm going to kind of factor the pi out of this thing. You could factor out both the numerator and denominator and deal with it later. See, 3 plus h squared. So we got 3 times 3 is 9, and then it's going to be plus 6h when you FOIL that, and then plus h squared, and then minus pi, and again our radius is 3 here, so pi 3 squared, so it's minus pi times 9. Okay, now pi is times all this stuff in the front here, so this is all over h. So what we've got is 9 pi plus 6 pi h plus h squared minus 9 pi over h. But if you notice what happens with you got 9 pi minus 9 pi, so that cancels out. So you're just left with 6 pi h plus h squared. I can factor an h out of the top and cancel that. When you factor the h out, you get 6 pi plus h in your numerator and h in the denominator. But remember, on all these, we're taking the limit as h approaches 0. The limit as h approaches 0. So let me write that here. Limit as h approaches 0. Well, I couldn't plug in 0 before because it was in my denominator. But now, when I cancel those out, remember, I'm not using 0 as a number. I'm just using a number really, really, really close to 0. So now I can substitute 0 into this thing. When you do 6 pi plus 0, you get 6 pi as your answer. And remember, it's area with respect to radius. So your area units, your rate of change is your change in y. It's area per radius. So you could say it's 6 pi inches squared, per change in x per inch there. And that's how you work number 25. So I'm going to write 6 pi inches squared per inch. That's my rate of change at this exact point when the radius is 3. All right, number 26 is very similar, except your formula is a little different. Now, the formula for volume of a sphere, our area is pi r squared, but volume of a sphere is 4/3 times pi r cubed. You set it up the same way. Use your definition of, your slope on the top of page 90, which is limit as h approaches 0 of f of x plus h minus f of x all over h. And then instead of the function being pi r squared, you just plug this as your function value. So we're going to take the limit as h approaches 0 of 4/3 pi. My radius is 2, so 2 plus h cubed minus, all right, now my function value evaluated at the particular x, which is 2 here. So minus 4/3 pi times 2 cubed. All of that over h, and we're taking the limit as h approaches 0. So try to finish this one.